We on? There we go. Hello. All right. Good Lord. Come on, man. This interface is terrible for the Twitch app. There we go. There we go. Hello, everyone. It's 4:30. Thursday, September 25th, 4:30 Eastern Time. Yes. We're already 4 weeks in. Hello. All right. You know the drill. Someone needs to chime in. Anyone in chat? Hey, Nick. How are you? Okay, Nick. All right. Mic check, audio check. Hey, Toasty House. Hello. Uh, mic check, audio check, video check. We should be good. Hey, Kevin. Hey, Kevin. Hey. Video sounds good. All right. Welcome. Week 4, episode 4. Season 11, Introduction to Security at Tufts. I'm Ming Chow, teaching professor at Tufts. Today, we're going to learn about an age-old problem. Very easy to understand, trivial to understand, extremely difficult to defend against. And that is the idea of a distributed denial of service attack. Distributed denial of service attacks happens all the time, every second on the internet. So the whole idea of denial of service is, well, denying people, access to a service. I'll give you a very good example. If you can't log into Facebook or Gmail, that raises red flag. People do call 911 when Facebook or Instagram goes down. Is denial of service is you're denied access to a service. Now, I did not mention anything about the distributed part. The distributed part is what happens when many computers on the internet, many people from around the world work together and bring down a service. Sometimes it can be inadvertent. I mean, how many of us have ever tried to order tickets for, let's say, a special event? Good example is a Taylor Swift concert. No one gets it. Many people don't can't get on it and buy tickets, because once they do get on, either A, they're already sold out, or B, more common or not, the website goes down. Another really good example is, anyone try to get the order the PlayStation 5 when it came out on GameStop or Walmart? I mean, those websites were just gone. They were hammered. And then, 15 minutes later, you found out, oh shit, the website is back up, but now it's all sold out. But more often than not, distributed denial of service, or DDoS, has a negative connotation, and it happens more often than you think. In fact, every second, someone out there right now is conducting a DDoS attack on for someone else or some institution. What's the value of DDoS? Why DDoS attacks? Chaos, nuisance, to affect someone's business, to affect to cut out people from companies from making money. I mean, now a lot of commerce is done online. Every second that computer systems are down and people can't buy the stuff that they need or want, that's money lost. There's a lot of hacktivism as well too right now. There are attackers like to use DDoS to bring down websites of certain institutions, like nonprofit organizations that believe in some certain cause. Happens all the time. So right now, if I go to Google, if I go to type DDoS in, and let's go to the news. I'm not a robot, dude. Oh, really? You know who I am. Hello? DDoS, you go to news. Come on, bro. 2 days ago, like we're talking 22, we're now in the terabytes when it comes to DDoS attacks. Kiev, DDoS attack knocks out Russian fast payment system, $30 million lost. Boom. Okay. Cloudflare is a company that also it's both a networking and a cybersecurity company. They do it for like a lot. Good friends. Their primary business is they're in the business to defend against DDoS attacks. That's what they're famous for. So here is the document. Like here, the idea of a DDoS attack is a malicious attempt to disrupt normal traffic by overwhelming a target or surrounding infrastructure with a flood of internet. That's it. It's just a flood a system or an infrastructure with just internet traffic. Okay. Now the effectiveness is usually is done by way of usually these days using compromised computer systems as sources of attack traffic. Okay. We're talking about like hacked webcams, baby monitors, stuff that you'll find on Shodan. Happens all the time. High level, a DDoS attack is like an unexpected traffic jam clogging up a highway, preventing regular traffic from arriving at its destination. I mean, that's a, this is what DDoS and DDoS attacks are. Now, how you do one? That's what we're going to do today. So today is going to be 3 parts. First part is going to be a technical overview of how a lot of modern DDoS attacks actually are conducted these days. Okay? The other thing, and then we're going to learn how you do them programmatically using Python. And then after that, we're going to have a guest speaker, the cybersecurity luminary John Hammond, who's going to actually use exactly what we're going to say in that middle part and learn how to take down the internet. And this talk has been made public. He did this for us back in 2020. You'll love it. Great, one of the best speakers around for cybersecurity. But let's go over how a modern DDoS attack actually works. Because you don't want to be sending, going to be almost impossible to have one single computer send so much traffic and hammer a computer and take down a network or a system. No. How modern DDoS attacks work? One of the big ideas is called an amplification DDoS attack. So there are 2 flavors. The first flavor I am going to talk about is something that is not used and done anymore for very good reasons. But the second flavor of amplification attack, that's still being done today. Now, how do you do it? What's a DDoS amplification attack? What is an amplification attack? So what it is you use lots and lots of computers, usually again, hacked computers or compromised computers. The attacker sends them, all those hacked computers, traffic that have a spoofed source IP address, forged source IP address. Yes, you can do that. And then all those hacked computers respond to the packet and then send the response back to the source, which in this case is going to be the computer with a forged source IP address. So back in the ye good old days, okay, so the idea is the more computers that you use, the more firepower you're going to actually have against your victim. So that's like a part 1 of an amplification attack. Part 2 is you need to exploit or use a protocol that actually you can forge source IP addresses. So imagine you are an attacker and you will control a botnet sending out 100 megabits of traffic. That's low. While that may be sufficient to knock out some sites online, it is a relatively trivial amount in the world of DDoS these days. So what you need to do to increase your attack volume, you can try to add more compromised machines to your botnet. Okay, So back in the days, it was okay. This is one of the Smurfs Saturday morning cartoon for those of you know. Now the original amplification attack was called the Smurf attack. Now Smurf utilized something called ping or ICMP. Ping is a very simple protocol, and I think I mentioned this last week. You know, ping. The idea is to check if a computer is up or running or not. So it's like sonars and submarines. You send a ping, you get a pong back. You send a request, you get a reply. No handshaking involved. And that's the caveat. There's no handshaking involved because ping is layer 3 of the OSI model. It's a networking layer. The only thing that really matters in ping is a source and destination IP address. That's it. No handshaking, no sequence number, no port numbers, no nothing. Okay? Here is the big idea. The big idea is this. The attacker spoofs the source of the ICMP request to be the IP address of the intended victim. Since ICMP does not have a legitimate handshake, the destination has no way of verifying if the source is legitimate or not. The router then sends a request and passes it all on to the devices that sit behind it. All those devices now respond back to the ping. The attacker is able to amplify the attack by a multiple of how many devices are behind the router. So here's a really good picture. So here is a picture of the attacker and the victim. The attacker will send 1, 2, 3, 4, 5 devices a ping, but the source IP address is forged to be the source IP address of the victim. So you can see, the attacker sends a ping to all 5 devices, but the source IP address is going to be that of the victim. So all these devices are going to send a reply back, not to me, but to the computer with the forged source IP address. And so all these 5 devices will send a pong back to the victim. And the victim is going to be like, what the F? This was how the White House, the U.S. government White House, was taken down in 1999. So if you add 15 more devices, you can see there'll be 5 plus 50. If you have 15 devices, let's say, then there's going to be 15 more packets that are going to be hammering the victim. 25 devices, 25 replies sent to the victim. 1,000 devices, which is a lot, victim's going to get like 1,000 replies, and the victim's going to be taken down. Okay, so the more devices you have, the more firepower that you're going to use to take down the victim. Now here's the thing, and this is the reason why ping has been turned off on a lot of routers, hardware, and even software systems these days, because ping has been abused for this reason, for distributed denial of service attacks. So by default, a lot of systems now just turn off ICMP replies. Configure the router to not relay ICMP requests to yada yada yada. However, even as this avenue has been closed off, it doesn't mean the idea is dead. In fact, it's very much still alive. So if you take a look at the underlying truth, the underlying fact, okay, so what do we need? We need a protocol. We need to, you know what, we can do something else. We need a protocol very much like ping that does not include a handshake. So can someone here tell me, what protocol does not use a handshake? I did mention this before, What networking protocol does not use a handshake? Ping is one. There's another one. Hint, hint. One that you use every day now for streaming. What protocol does not have a handshake? Okay. Camsman says UDP. That is correct. FTP is TCP. FTP uses TCP. So that has a handshake. So it's not FTP. UDP does not have handshake. So FTP, TCP, no good. UDP, yes. So Cam's man, No, this is good that you get. I mean, we might as well get it wrong now. But here's a follow-up question. What else? Does anyone know what uses UDP primarily? What application uses UDP? We're not now. I'm getting the right answer I'm looking for. Not streaming. Does anyone know of a certain, you know, application or program that is critical to the internet that uses UDP? There's a few things that use UDP, but this one is a big one. I'm going to actually fire up my command line terminal for this one. Anyone know? Okay. Believe it or not the Internet of Things. Anyone ever heard of DNS, domain name systems? DNS. Domain name system. Some DNS use TCP, but DNS generally uses, a lot of them use UDP. Okay? Here is what DNS is. You're on the web, you're on the internet. Would you rather remember harvard.edu, or would you rather remember 128.103.244.118? Would you rather remember harvard.edu, or would you rather remember the IP address? Of course, you always remember the domain name. Okay, you always want to use the domain name because it's human friendly. But anytime you use a domain name, it got to be translated into an IP address. So DNS is a lookup tool that translates domain name into an IP address. And that tool, that DNS uses UDP. Does anyone know the command line program? Does anyone here know how you actually can do a DNS lookup using a command line? Does anyone know? Anyone know the command to do a DNS lookup? Anyone? Clear the screen. Anyone that don't know the command? Dig. Dig. Dig is a DNS lookup utility. Okay? So, I want someone to say, how many letters do you see on the screen right now after the $sign? After $, how many characters are there? It's a simple question, not a trick. Three letters, as Nick said. Correct. 3. Plus a space is 4. We're going to use harvard.edu. So how DNS looks like, DNS lookup is dig, space, your favorite domain name. In this case, I'm actually going to use harvard.edu. So now, how many characters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 characters. Now remember, so the input size is 15 characters. Now remember, DNS does not use a handshake. That means you could forge the source IP address of a DNS request. Now I'm going to hit the enter key. So we have 16 character as an input. And here's your output. Harvard is 192.0. Okay. That's messed up. Huh. Okay. That's really strange. How many characters are here? What's the output size going to be? Character count. 463 characters. So we have 16 characters as an input. 16 characters input resulted in a 463 character output. That's like a 28.9 time increase. That's a 28.9 time payoff. That's pretty nice. So imagine if you slam a victim with all this data. That's not bad at all. Okay? So 16 characters input resulted in a 460, around 460 something character output. And you send all this to a victim? If you forge the DNS source IP request source IP address, that's a pretty damn good. And that's what DNS amplification is. So there are two criteria for a good amplification vector. Number one, the query can be set with a spoofed source IP address by way of a protocol like ICMP or UDP does not require a handshake. And number two, the response to the query is significantly larger than the query itself. The query in this case is dig space harvard.edu. Dig homework.cs.tufts.edu. That's a little long, and you can see there's a whole bunch of 130.64 addresses. That's a lot more than 400 characters. Okay? DNS is used everywhere. It's just built into every single operating system, software. Like, it's absolutely necessary for things like the web to work, like your web browser. You're not going to type in IP addresses all the time. It has to do DNS requests anytime that you actually type in, like, reddit.com on your URL bar. So DNS queries are transmitted over UDP, meaning like ICMP queries used in a Smurf attack, they fire and forget. And yes, you can forge the source IP address of DNS queries. As a result, the source can be spoofed. Oh, here it is. Can be spoofed, and the receiver has no way of determining its veracity before responding. DNS is also lovely because it can be capable of generating a much larger response than its query. For example, you can send the following tiny query where you have an IP address of an open DNS resolver, and you get back a gigantic, this is what we just did moments ago, you get this gigantic ass response. And so that's a 64-byte query input that resulted in a 3,223-byte response. In other words, an attacker is able to achieve a 50-time amplification over whatever traffic they can initiate through an open DNS resolver. Okay, not bad. So this is really, really, really cool. No, this is live. The OS for domain names to create user for illusion. Yes. Yes. So now the thing is, can you do this programmatically? Wait a minute, so you may be wondering, can I do this at my home? Can I actually do this using like a programming language like Python? And how do you spoof the source IP address? You can do all of that. In fact, later today, you're going to see DNS amplification, how it's done, and you'll be shocked. To do DNS amplification, DDoS attacks, it's only going to take a couple of lines of code. Literally, yes, only a couple lines of code. It's crazy. Okay? So now, let's talk about how you do this. All right. Let's see how you do this. All right. So I'm going to go to my desktop. There's a Twitch folder here, but I'm going to move it to the trash for now. Okay? So now my desktop is empty. I got nothing. And I want to introduce you to Scapy. Scapy.net. Scapy is a Python library. You need to know a little bit of Python. That you can do packet manipulation. You can create packets, you can read packets, you can write packets, you can send packets. You can do a whole bunch of things. You can, even read PCAP files. Pretty nice. The one small problem is it's slow. Scapy is also in Python are both platform independent. You can use it on Linux, Mac OS, and even Windows. You can use Scapy as a command line tool like this, or you can write a program that uses a Scapy library, which is your lab number 4, which is the lab for this class. So if you go to cs116.org, you go to lab number 4, and here are your details. This is publicly available. Anyone can do it. Anyone can actually have access to this. You're going to write an incident alarm. You know how, remember in lab number 2, we did Wireshark 2 weeks ago? And you use Wireshark to, what? Open PCAP files, rip out username and passwords in PCAP files. Remember that? Why are you going to do that here? What if this time you don't use Wireshark? You're basically writing like an El Cheapo version of Wireshark that rips out usernames and passwords. Yes, lab number 2, you're using a tool. Lab number 4, this incident alarm, you're writing the tool. So in this lab, you're going to be writing a Python program called alarm.py, called alarm, that is going to, idea is to analyze either a live stream of network packets or a set of PCAPs for incidents. So this alarm, you're going to need to detect no scan, bin scan, Christmas tree scan, username and password sent in the clear by way of HTTP basic authentication, FTP and IMAP, NICTO scanning, someone scanning for SMB, someone scanning for RDP, and someone scanning for VNC. Okay? And here's the beautiful thing about it. I even wrote the code. I even wrote a good starter program for you, which we will use in a little bit later. So, okay, how do you use Scapy? Well, the first thing that you need to do is you need to install Python 3 onto your program. So using homebrew, brew, install Python 3. I'm on Mac OS. I'm the latest version of Mac OS. And as you can see, I have the latest and greatest version of Python, 3.13 on my Mac, on 3.13.7 on my Mac. Now I'm on my desktop. I'm going to make a directory called Scapy. You know what? I'm going to make a directory called alarm. We're going to do a lab number for a part of lab number 4 for you. I'm going to help you get started. So I'm going to cd into alarm. Now I'm going to do an ls. There's no files, no nothing installed. What we need to do now is we need to enable something called virtual environment for Python. What is a Python virtual environment? Python has a built-in tool, has a built-in library called virtual VENV. So what Python virtual environment is to create an isolated space for your Python projects, like all the dependencies are within the folder and do not interfere with the entire system. Back in the ye good old days, it was really easy to really mess up your entire operating system. Like if you installed, Python libraries and programs, and they just took over whatever was on your system. No. So think of a virtual environment now as like a sandbox, okay? And that it doesn't affect the entire operating system. This is like Python virtual environment is awesome. It is now like the way to build any Python program. Now to set up a Python virtual environment, assuming that you need Python 3, Python 3 minus VENV for virtual environment, and give a name for your virtual environment folder called, I'm going to call this ENV. And that's it. So as you can see now, there's a folder called ENV created. So I'm going to show you what this ENV folder looks like. And it will, as you can see, it just has a shortcut to the actual Python libraries. But what's beautiful now is that you can go and install Python libraries, for this project in this folder, and it doesn't affect your entire operating system. The next thing we need to do is to enable this Python virtual environment. So you will do, so I am in my alarm folder, you will do source, env, activate. And you can see now next to my name of my computer, you can see inside of parentheses env. You see a parentheses and then like an env, preceding your computer name. That means a virtual environment is activated. Okay, so now what we're going to do is we're going to install Scapy. And to install Scapy, you would do pip install Scapy. Or you can do pip3 install Scapy. Now I'm going to open up another terminal shell for you. And I am going to show you what happens if you try to do pip3 install or like pip install Scapy without any virtual environment. So I'm in my documents folder. First of all, pip is not found because now it's called pip3. But now you'll get a warning, you'll get an error. Actually, it's an error. This environment is externally managed. To install Python packages system-wide, you have to do brew install XYZ, where XYZ is the package that you're trying to install. To make a long story short, you can no longer install Python packages using pip or pip3 in a non-virtual env folder. So it's to say use a virtual environment. Okay? So now in this folder called alarm, and then I have enabled virtual environment for this folder, you can run Scapy. Just type Scapy. And now what we are in, is what we call command line mode, CLI mode. So if you're going to want to play around with Scapy, like creating packets, this is the place to do so. Okay? So, I'm going to fire up Wireshark, and I will show you how to send a ping packet using Scapy. Now, I am going to opening up Wireshark, and I'm going to sniff on I'm on wire. And you can see this is the entire Twitch stream, all the packets from the Twitch stream between my computer and Twitch. But now I want to just filter I only want to show ICMP packets. Ping. So I'm going to say have a variable packet equals IP for the IP layer. This is where you can set the source and the destination. If you don't set the source, it's going to use your IP address by default. So the destination in this case is going to be, so DST equals, inside single quote, 192.168.1.18. So the nice thing about how you can create packets in Scapy, it's like the OSI model layer. It's all based on layers. So the first thing that you set is layer 3, the IP layer. And then you can also set the TCP layer if you want next, which we are not going to do. But in this case, we're just going to create a ping packet, and we're just going to say ICMP. So packet is going to have a destination of 192.168.1.18. This is a ping packet, and I'm just going to hit enter. Now I have created a packet. So if I type packet again to print it out, and you can see it's an IP packet, protocol is ICMP, destination 192.168.1.18 is ping packet. You can also pretty print the packet, pretty print. It's like there is a function in Scapy, show. There is a show function in Scapy. If you do show packet, oh damn. Oh, packet dot show. Bing. You can see all the different layers. IPv4, the length of the packet, the protocol, the source, and the destination. So my local computer IP is 192.168.1.18. And in the layer, this is an ICMP packet. Okay, so I type packet again, but now, of course, the nice thing is you want to send it. There's a send function in Python and Scapy. You send it. Look at that. I hit the up arrow again. You can see the request and the reply in Wireshark. And you can also review like, yeah. If you drill down the data, it's gonna match exactly what you see here. Time to live is 64. Is time to live 64? TTL 64. There you go. Send another ping packet. You see it in Wireshark. Really nice. So this is how you create a packet in Wireshark. Now, how can we send a ping packet but set the source to be something else, to be anything that you want? Sure. Packet, the IP layer, set the source. We're going to set the source to be, to be our friend. Oops, shit. To be our friends. This 1.1.1.1 is the DNS. 1.1.1 is Cloudflare DNS. DST, the destination, is 192.168.1.18. And this is an ICMP packet. So I'm going to do packet.show now. And you can see now the source IP address of this ping packet is no longer my computer, but it's forged to be 1.1.1.1 or Cloudflare's DNS. Really? You don't believe me that 1.1.1.1 is Cloudflare? There you go. 1.1.1.1 is a free domain name system service by Cloudflare. Yep. Can you send it? Now, what happens if you send the packet in Wireshark? What will Wireshark look like? The answer is, it should not be a surprise if I hit the enter. If I hit the enter key. Come on, man. I'm going to hit the enter key now. You're probably not going to see anything happening in Wireshark. Oh, it did. Oh, I have promiscuous mode. That's why. Duh. So now you can see the source is 1.1.1.1. Destination is 192.168.1.18. But of course, the request gets sent, but you don't see a reply. Do it again. I have promiscuous mode, so of course I can see the request. I just can't see the reply. But it makes sense because the reply is being sent to 1.1.1.1. Yeah. So yes, you can forge the source IP address to be anything that you want in a tool like Scapy. Okay? Well, wait a minute. Can you also do this for UDP as well? How do you create a UDP packet? Wait for a little bit. Just wait for a little bit. Okay? So now, this is what you call the command line interface option for Scapy, the CLI. It's not fun. I mean, if you're going to do like little demos or little proof of concept, the CLI is good. The interactive console is nice, but more often than not, people are going to write Python programs using whatever their favorite code editor is, and using the Scapy library. So now, I still have my virtual environment enabled, and I'm still in my alarm folder, and here. It's only on the NB folder here. That's nice. But now, let's write a Python program that uses Scapy. So what I'm going to do now is I'm going to take, this is from Lab 4. And I said already here, get the starter code. I made the starter code publicly available. I am going to copy all this code. Now I'm going to fire up my favorite code editor. I'm going to use VS Code for today. I'm going to call this alarm.py. And I'm going to paste. Now, for lab number 4, for this lab, all you need to do, do not modify the code below. You only need to modify this one function, a callback function called packet callback. Okay? Now, what is this function called packet callback? Whenever you read in a packet, read in a PCAP file, for each packet in the PCAP file, each packet in the PCAP file will go through this function called packet callback. So yes, think of this program as just going to loop through in all the packets in a PCAP file. But for each packet, it'll go into the packet callback function. Okay? Right now, there's only one thing that is in the packet callback function, which is if the destination port and it is a TCP packet and has a TCP layer of 80, that means there's some web traffic in there. Okay? Alright, this is no good if I don't show you. So I'm actually going to show you. I'm going to quit out of here. So here I am. I have more alarm.py. It's everything that you see in Visual Studio Code, but let's download set1.pcap from lab 2. I'm going to save the set1.pcap to my desktop and to the alarm folder. Hit save. You know what? I'm also going to, just for the fun of it, I'm also going to download set2.pcap just for the heck of it as well. So now, in my alarm folder, I have not one but two pcap files, set1 and set2.pcap from lab number 2. We're going to use this Python program, alarm.py, to analyze set1.pcap and set2.pcap. So how you run the program is the starter code that I gave to you. I didn't make any changes to this thing. I just copied and pasted the code. So what you can do now is having virtual environment enabled. I don't need this anymore. Get this out of here. Python alarm.py. And I'm going to hit the enter key just so you can see what's going. Let's see if you can. By default, it's going to sniff on ETH0. Well, this is no good because, if you're going to be sniffing any traffic, and I mentioned this, but definitely I mentioned this before, if you're going to do any network sniffing packets, you're going to need to run in a sudo. But we're not sniffing packets here. We want to read in set1.pcap or set2.pcap. So if you do Python of alarm.py, there's a help option here. So you have two options. -I is sniffer mode, -R is PCAP reading mode. So what you do is Python alarm.py -R set2.pcap. So we're going to use alarm.py to open up and read in set2.pcap, and notice what will happen. Bing! Whole hell of a lot of HTTP web traffic detected. So there's a lot of HTTP packets here. Okay, now if I try to open up set1, you need the -R flag. set1.pcap and alarm, not going to do anything. The reason why it doesn't do anything is, if you remember from set1.pcap from lab number 2, it was all FTP. So we can modify the program. So what we need to do is this. So we're going to write a loop called elif packet sub TCP the TCP layer. If it has if there is a TCP layer and there's a destination port of 21, print FTP detected. Okay, so if the packet has a TCP layer and there's a destination port of 21, boom, FTP detected. Nice. All right, let's dig a little bit deeper. You know what? Why don't I just cancel out all these lines? Can you print out all the text data, like all the FTP payload data, like the text, the strings? The answer is yeah, absolutely. But before we do that, well, we can also do this another way. If packet.has layer TCP print TCP. So this is another way if you want to, if you want to make it a lot more clearer and you don't want to use a square bracket notation. Oh shit, nothing. Wait, why is this happening? Well, the reason why I'm showing you this is because sometimes what this program does by default, any syntax errors will not be printed. It will be escaped by way of exception handling. So what you need to do is to uncomment the print the exception line below, comment pass, find the error, and comment pass. Now watch what happens. Has layer. This makes no sense. And that makes sense because you have a typo here somewhere. So I'm gonna go back here, and now this is why sometimes, having an LLM, Scapy has layer. Is it has underscore layer or has layer? Has layer. If packet has layer, not has underscore layer. Ooh, a whole bunch of prints here. What happened? Reading in set 1. Oh. Save it now. Okay, that works now. What I can also do is packet.show, like what I did earlier. So I'm going to show all the packets in its full glory details. There you go. Actually, I'm going to clear the screen, but this time I'm going to do a pipe more so I can only show the first couple. Alright, so what we have, you can see the TCP flags here. Sync, this is an S. Sync-ACK, okay. That's an ACK flag, okay. So if you want to show just the TCP flags, I'll comment this out. Print packet of TCP dot flags. So if packet has a TCP layer, just print out the TCP flag. And if I do this again, you should see sync, ACK, and ACK as the first 3. Sync, and ack. Sync, synac, ack. Okay. How about payload? What about the text? Well, I want to comment this out. Now I want to do a packet.show. And there should be a layer. Yeah, here it is. Load. L-O-A-D. Remember this one? Absolute unit LFG. I'm going to quit that. Can we actually do a, instead of packet.show, to print the packet.layer, .load? Print packet sub TCP.load. There you go. You can see the image data. That should be binary image data, right? Should be a picture here. There you go. Transfer complete. Quit. Goodbye. Way cool. So you can see the text strings and stuff. Wait a minute. What about set2.pcap? Can you see all the data as well? Yep, sure. You can see authorization colon space basic. You can see it all. So again, in this program that you're writing, you're essentially building an El Cheapo version of Wireshark, but with really like tight window of things to look for, not like everything. So this is what you're going to do in lab 4. The 4th lab, you're writing a Python program that uses Scapy to analyze PCAP files for things like the stealthy scans, username and password sent in plain text, someone is scanning RDP, what is it, 3384? RDP port is 3384? I think it is. My 3389, jeez, I'm a little slow today. 3389 is Wireshark. That's all you really need to look for. But now I think you're all looking for. Wait, now you have a little bit of a crash course on Scapy and how to use Scapy. It should be enough to let you finish Lab 4. What about taking down the internet? What about using Scapy for DDoS? And that I'm just going to turn this over to my friend John Hammond, who's going to talk about bringing down the internet. Take it away.
Alrighty, hello everyone. Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously, I know things are a little crazy and weird and not how we're used to them being at DEF CON, but thank you so much for being oriented stuff. So naturally, we're going to be talking about packets, using Scapy, using Python, and we'll dive into that more. But I want to say, the title of this talk, right, the whole theme, Take Down the Internet, that's going to be doing a lot of kind of jerk stuff. It's about obnoxious, annoying, adversarial, and disruptive attacks. So nothing like elite, super cool, 0 days, crazy like Ninja Warrior, cyber hacker stuff, but really just being mean and breaking stuff. We're trying to recklessly break stuff. I want to showcase some of this to you because I want to show you just how easy it is and how Python, just the same scripting language that's about on every Unix system, can do this stuff, and how you could do it if you really wanted to, but you shouldn't. You don't have to, right? Take down the internet. Obnoxious, annoying, adversarial, and disruptive attacks. That's the background. All right, now let's talk a little bit about Python. I'm going to be using Python as the vessel for this talk, right? We want to make this a little bit of a technical talk and showcase some code, showcase some real stuff, rather than just pointing at numbers on a graph. So I want to lay the foundation again with Python. Python is a wonderful hacker's language. Yes, it's a scripting language. It's not compiled. It's read through an interpreter, but it is easy to read and easy to write. That means that it's super duper friendly. It's really easy to knock out quick testing scripts or to rapidly prototype some ideas. It's just handy and useful and has a lot of support between all the different libraries and modules and packages that you could pull into your code and do some really, really neat stuff. So there's some conversations, right? Because now we are in a new era. We are in 2020 and Python 2, the older version of Python, is dead. It's not on the table anymore. Python 2 reached end of life at the start of this year, and now Python 3 is the officially supported version. Please don't hate me for screaming about that. I just want to make sure, hey, everyone knows we're using Python 3 and you should be too. And of course, Python is part of Linux. It is typically shipped and natively kind of built into a lot of common Linux distributions. And honestly, you should be using Linux. I don't know why you wouldn't be. And because it is part of Linux, it's really, really easy to access it just from the command line. You can simply type in Python, and then you're inside of an interactive shell or interpreter to work with the Python language. I'm kind of being explicit here. I'm using Python 3 with that suffix 3 at the end. You probably will just be able to invoke it as regular Python, and maybe that would spin up Python 3 for you. But if it does, fire up Python 2. Hey, you should know better. Go fix that up and hop over to Python 3 now as the officially supported version. Python, while we could be working inside of the language within the interpreter or within that shell, oftentimes you'll likely want to create a script or file with a .py extension, maybe a shebang line, and you can invoke it and run it with Python just as an automated tool, not manually working through the interpreter or the interactive shell there. In a lot of our conversations, what we'll be discussing, I am assuming you're going to end up using this inside of a script with a .py extension, and you don't need that interactive interpreter. Okay, let's move on because you probably all already know about Python, and this is boring. So let's talk about Scapy. Scapy is incredible, fantastic, phenomenal. It is a module, it's a library, it's something you can just install, pull in to use with your Python code, and it gives you the ability to craft network packets. You can customize them, you can forge them, you can create them, you can whatever you want, your wildest dreams, whatever sort of network layers or protocols or things that you want to use, you can get that fine-tuned, like zoomed in microscopic customization of what that packet looks like. And that's super duper cool. It's easy to install. I'm showcasing some commands here. I'm assuming, okay, a Debian-based distribution, maybe Ubuntu, you'll do a little sudo apt update and you'll install pip if you're working with that little handy Python package manager. And let's use pip install Scapy. Now, you could run Scapy in one of two ways. Very, very similar to what we talked about in Python, right? Scapy could be interactive, and you could work inside of an interpreter with a manual, like typing in commands and getting that returned back to you, like interactive shell. Or you could work with it inside of a script and have Python just import Scapy as a whole module. And you can access all of the code, the functions, the variables, all of that functionality that Scapy offers inside of your Python scripts, inside of Python. Now, this is crazy cool because we can work with TCP packets, UDP packets, any other network stuff, maybe CAN bus protocols or Bluetooth. There's so much more, and we could dive into some of the documentation for Scapy. I always want to point people to the real documentation because that's where the real stuff is, right? I'm not going to be the expert, sorry. I don't think you would call yourself the expert, and I'm not saying that to be mean. I'm just trying to say the source code is the truth, right? Documentation is the real accurate stuff. That's what's really there, really built in. And the official source, it's what's good to go to when you need help or you're trying to learn something new. Obviously, there's a man page for the command if you wanted to fire that up. Obviously, they've got an online web presence. You can check them out at scapy.net. And they have official documentation over at readthedocs.io. And of course, a GitHub page. So you can go take a look at the source code. It's open source. It's awesome. It's all Python, good stuff. The website is actually fantastic. They have a page over there called Awesome Scapy, and that will showcase other tools, exploits, and some sample code to use, and it's really, really cool. They have some good stuff on Wi-Fi, like mapping and tracking Wi-Fi networks through 802.11, making a roaming access point, performing some man-in-the-middle attacks, some Tor, onion router protocol stuff, tons and tons of great stuff. Even CVEs and exploits for common attacks, or stuff from Crack, the attack against WPA2. Super duper cool. Really recommend you go check that out. Okay, now let's talk about the basic syntax of Scapy, because if we want to use it, we have to know how to. I say that Scapy is Pythonic in that the syntax that it uses when you're working with the module, you're working with Python objects, right? The same way most everything in Python really is that you're interacting and working with an object that has methods and properties and all these attributes and things you could work with that are really under the hood, right? Functions and variables, just with a kind of a different decorated name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter, and I'm going to use that from scapy.all import everything, or the asterisk, the star, the wildcard, to pull in everything that Scapy module has into my current namespace, so I can interact with it and I can work with it through Python. So here I'm going to create an object or a little variable, ping equals, and the IP, this big class name, right? You can see the capital letters there. That's going to return a Scapy object, and it's going to be a packet, and I can define how that packet looks. Maybe I don't want to use an IP, or maybe it's that specific header for that protocol. I could zoom in on other things between TCP, UDP, HTTP, or anything else. ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DOS attack, which will make that server, your victim, unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN ACK packet, or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, the server, while it sends that SYN ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. that will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet, the very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped. And we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, in this example, with this setup right here, we're sending this SYN flood attack just with our attacker machine. One machine. So potentially, that endpoint or that target, the victim server, once it realizes, hey, I'm under attack, right? I'm in danger. If they kind of had the opportunity to look through some logs or could figure something out and determine, oh, I know the source of this attack, I can just block it off. Well, you're totally right. That's absolutely doable. For that reason, this kind of thing isn't often done just with one host, just with one attacking machine. So you bring in the conversation, okay, we're performing a denial of service attack, a DOS attack or a DOS attack. But if we had more machines in this pool, if we were attacking with multiple hosts, we could be performing a distributed denial of service attack, or that DDoS. That might make it a little bit harder to do, harder to track down, harder to trace. However, we could do even more. We could go one step beyond that when we say our source IP address, we don't want that to look like it's coming from us. We want to hide it. We want to mask it and obfuscate that just a little bit more. But you can tell with Scapy, we are crafting our packets at the granular level. What's to stop us from specifying just that information, just the bytes, the real information that we need within that header of the packet? We could say that our source IP address comes from a different IP address, comes from a different host. We can spoof our IP address simply by passing in the keyword argument. Just as you see the example there, we specify that DST keyword argument as an IP address string. We could just as easily specify SRC, or the source IP address, and make it look like we are coming from a different location. We can spoof our IP address super easily with Scapy. And we can use that as a segue into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that SRC keyword value, or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port or the destination port to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. That will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or a normal human explanation, say you are at the drive-thru ordering some fast food to go or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger or I want one drink or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss BGP abuse. So BGP is the Border Gateway Protocol, and that is the standard routing protocol of the internet today. That means that it's actually telling your computers where these packets are going to go when you're working on the internet or at a large scale, the wide area network, right? So routers using this BGP or the Border